Okay, so this is the final video for chapter 5 for this week. It's going to be on the nuclear atom. So our goal is to describe and interpret the Rutherford scattering experiments and the nuclear model of the atom. And like I said in a previous video, I think this is a model that many of us are familiar with, or we've seen at least before, maybe even on a t-shirt. So here's Rutherford. So in 1910, Ernst Rutherford, Hans Greer, and Ernst Marsden, I think I'm pronouncing his name right, performed a series of experiments usually referred to as the Rutherford experiments. And here's a video on that we're going to watch. So you're watching a YouTube video of a YouTube video. So it's like YouTubeception. So here we go. Hopefully this comes through.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
Okay, so hopefully that came through. I'll see as I'm looking at the videos after recording this. So the alpha particles, when they collided with something, were reflected back, right, or scattered. So as we said or saw, only a small fraction of them did that. So putting these two things together, that's what Rutherford did and came up with the following model. After I switch. No, we don't want to see that again. Okay, so the data from Rutherford's experiment led to the following conclusions that are now called the nuclear model of the atom. Okay, so here's a summary of that model. Every atom contains an extremely small, extremely dense nucleus. That was the thing that the alpha particles were scattering off of. All of the positive charge and nearly all of the mass of the atom are concentrated in the nucleus. The nucleus is surrounded by a much larger volume of nearly empty space that makes up the rest of the atom. And that's why most of the alpha particles went through the sample. And then the space outside the nucleus is very thinly populated by electrons, the total charge of which exactly balances the positive charge of the nucleus. And this is the model we saw before. So this guy is the nucleus, right there. And these are the electrons, okay, that surround it. So if we look at this a little bit closer, the relative sizes of an atom and its nucleus are shown here. So the diameter of an atom is approximately 10,000 times the diameter of its nucleus. And that's shown here. So the nucleus is made up of protons and neutrons. And it says this nucleus is 1 centimeter in diameter, let's imagine. That means the diameter of the region occupied by its electrons would be 100 meters. That's really long to kind of put it in scale for us. And so from this, the planetary model of the atom in 1911 was made. So where electrons travel in circular orbits around the nucleus, much like planets move around the sun. And this is the thing that I said that you've probably seen on a t-shirt, or maybe you have a t-shirt with this on it, or a mug, or who knows. But this is the model that many of us are familiar with. So that's it for this section, or this week's videos, I should say, not this section. And in next week's videos of chapter 5, we're going to be talking about isotopes and diving deeper into atomic theory. So see you then.